Good morning, everyone. Welcome to math class. Thanks for being here again today. We're going to get our day started with the do now activity. If you pull out the worksheet from your envelope that looks just like this, there are several pages stapled together, and you turn this thing over, the very back page is our do now activity for today. I'm going to get that up here in just a second. It looks just like this. It's a little bit of review with perfect squares. We're working with square roots and exponents because we're going to work with those quite a bit as we study the new concept, the Pythagorean theorem. Okay, right now if you want to pause the video and work on this yourself, you're more than welcome. If you want to work with me through the first few problems to figure this out, you can continue to follow along. Okay, the directions say that a perfect square is a number whose square root is an integer. Okay, so that's a positive or a negative whole number. Okay, half of the first 30 perfect squares are listed for you. Fill in the other 15 perfect squares. You'll notice your worksheet looks a little bit different. It doesn't say 30, it says 300. I just went right here. I can go like this. Let's just go like this. Oh, no, not yet. First 30 perfect squares. Okay, the first example says the square root of 1 is equal to 1 because 1 squared is equal to 1. 1 squared, 1 to the second power. That's just like saying 1 times 1. The exponent tells you to multiply the base by itself 2 times. Okay, the next example there is blank. Okay, right next to the equal sign, there's a 1. The next one's going to be a 2. After that, it's going to be a 3. After that, it's going to be a 4. Okay, and then we're going to follow along. Over here we had a 1, so here we're going to have a 2, and here we're going to have a 3, and here we're going to have a 4. And 2 to the second power, 2 squared, that's the same thing as 2 times 2, and we know 2 times 2 equals 4. So now we've got our second perfect square, which is 4, and 3 times 3 is 9. So the square root of 3 equals 9 because 3 squared equals 3 times 3, which is equal to 9. And down here, 4 squared is the same thing as 4 times 4. The base times itself 2 times, and that's 16, so we'll put a 16 over here. If you're following along with me, now's the time to pause the video and finish this thing on your own. You already have 5 right there, so you're going 6 right here, and continue. I'm going to the class notes for today, and we're going to start talking about the Pythagorean theorem. All right, let's see. On the first page, you can see I've highlighted some things. The expectation is that when we finish this unit, Module 12, you can explain a proof of the Pythagorean theorem and its converse, and you can apply the Pythagorean theorem to determine unknown side lengths in right triangles in real-world problems and mathematical problems in 2 and 3 dimensions, flat things and 3-dimensional things. Let me see something here. Let me see. If you go back into the classroom and you go right here, there will be some class notes, and I'll get those. Let's see here. Class notes, edit. We'll get those going for you. This is a copy of the class notes. And in there, you can click on that and you'll have the blank template, basically. So you click on this. You can see there's a different little symbol right here where my cursor is. Then this one above it. The one above it is going to be an assignment. The class notes, that's just a resource. Okay, resources. Lecture notes and classwork, and then your assignments look like that one right there. Okay, if I click on those class notes, Let's see what happens here. It says this is a template for note-taking from the class lecture. There was a printed copy in the folders you got from the school today. You click on that, and it's going to bring you right to a Google slideshow. And you should be able to probably click on those links, those blue highlights, and they'll bring you to some videos that give more explanation and more working through problems on YouTube. So I'm going to go back. You can see, you can also just type that into your web browser. Okay, I'm going to go back to where we were right here, and I'm going to go to the next page of the notes. All right. This one, I'm going to get rid of all this stuff and start over new for you. As you can see, I've already kind of done this. We're going to do it again together. Figuring out the technology. This is, I've tried a few times now, and I think I've got it. I've got it figured out. I think we'll get it this time. Okay, the directions here say find the square of each number. So all I'm doing is squaring each number. And 5 squared, if I type that into my calculator, I push 5 up 2, or 5 times 5 equals 25. Okay, over here we're doing the same thing. We're raising 16 to the second power. We're finding the square of each number. 16 times 16 equals 6 and 9 and 6 and 1, and so that's 256. So 16 squared is 256. Again, you can type in your calculator 16 up 2 and you will get the same thing, 256. I'm going to try and move along quickly here. It's telling us to take the square of each number. So I'm going to take the square of -11. If I'm typing that into my calculator, I need to make sure that I put that -11 in parentheses. Or what I'm doing is -1 times 11 squared, which is going to give me -121. But we know that if we take -11 times -11, a negative times a negative is going to be a positive. Okay, so always remember that. If you have -11 squared, your result is going to be a negative. If you have -11 squared, your result is going to be a positive. Okay, the difference is where the negative symbol is. Let's go on and find the square of a fraction. Okay, this is just basically, I need to multiply 2/7 by 2/7. And if I multiply fractions, I just multiply straight across, I'm going to get 4/49. And I can't reduce that at all. 49 is a prime number. We're going to go on over here and we're going to evaluate some expressions that have parentheses and exponents and square root symbols. So here it's really important for us to remember this rule of order of operations, PEMDAS. Please excuse my dear Aunt Sally. I'm going to start with parentheses. I'm going to add that 6 and the 2, and that's going to give me 8. And then the next thing I'm going to do is my exponents, because PE, parentheses, exponents. So 8 squared plus, let's see, what's 3 plus 3 is 6. So I have 6 squared. And let's see here, 8 squared, use your calculators if you need to, that's going to be 64, and 6 squared, that's going to be 36. And if I add those values now I'm over to the A, add them up. 64 plus 36 is 100, and the square root of 100 is equal to 10, because 10 times 10, or 10 squared, is equal to 100. So that is the evaluation of that expression. In my calculator, to do that, I'm going to push the keys second, then I'm going to push the x squared key, and then I'm going to type in whatever the radicand is. In this case, it's 100. The radicand is the number underneath the radical symbol. And then I'm going to press equals or enter. Get this out of the way. And that's going to give me 10 in that case. Okay, we're going to go over to number 6, and we're going to do the same thing again. We're going to follow our order of operations rules, and we're going to do 9 minus 4 to start, and that's 5. And I know 5 squared is 25. So I just skipped a step there. Right, and then I'm adding. 5 plus 7 is 12, and 12 squared, or 12 times 12, is 144. And then I'm still finding the square root of that value. So what I'm looking for is the square root of 25 plus 144, which is 169. And if I type that into my calculator, again, the keystrokes are second, the x squared key, the radicand, which in this case is equal to 169, and the equal sign. I'm going to find that that's going to be 13. Now, let's move back over here. Let's see here. Now we're working with 10 minus 6 squared. Plus 15 minus 2 squared. 10 minus 6 is 4. 4 squared is 16. So I have 16 plus, that came from right there. 15 minus 12 is 3. 3 squared is 9. 16 plus 9 is 25. And the square root of 25 is equal to 5. Equals 5. Again, second, x squared, this time it's a 25, and then equals, and you're going to get 5. Okay, same idea here, rules, order of operations rules. 6 plus 9 is 15, 15 squared is 225, then adding. 10 minus 2 is 8, and 8 squared is 64. Again, I'm working inside parentheses first, then I'm evaluating the exponents, then I add these values under the radical symbol, and I get 289. So the square root of 289 is equal to 17. That's my answer right there. A little more practice. A little more practice. Okay, this one, we move down the page. It says simplify each expression. Evaluate, simplify. What is this equal to? I'm going to multiply all 3 of these values. This parentheses just tells me to multiply 5 times 8 and 8 times 10. And the order that I multiply these does not matter. It's all multiplication. So 5 times 8 is 40, and 40 times 10, I just have to add one more 0. And then over here, again, multiplication, multiplication. 1/2 times 6 is the same as 6 divided by 2. If we multiply by a fraction, it's the same thing as dividing by the denominator. right? We're multiplying straight across, so it's 6 over 2, or 6 divided by 2, which is equal to 3. And 3 times 12 is equal to 36, right? 1/2 times 6 equals 3, and 3 times 12 equals 36. Doesn't matter what order you type those into your calculator. Try it out. Do 12 times 6 divided by 2. Over here, again, 3 is equivalent or equal to 3 over 1. 3 divided by 1. If we multiply fractions, we multiply straight across. 3 times 1 is 3. 3 times 1 is 3. 3 divided by 3 is 1. 1 times 12 equals 12. Right? 1/3 times 3 equals 1. And 1 times 12 equals 12. And when we move down to the next row, something changes. All of a sudden, we're working with exponents. And remember, we have to do what's in parentheses first. We don't have to do anything to the 8 or the 4. So the next thing we need to do is square that value of 8. So it's going to be like 1/2 times 64 times 4. And now it's all multiplication, and it doesn't matter which order we do this in. I can do 1/2 times 4 is 2, and 2 times 64 is 128. Or I can do 64 divided by 2, or multiplied by 1/2, is equal to 32, and 32 times 4 is 128. Again, the order doesn't matter. On to number 13, we have an exponent again. Nothing happening inside parentheses, so let's square that 10 and get 1/4 times 100, because 10 times 10 is 100, times 15. And if I multiply 1/4 times 100, or divide 100 by 4, I get 25, and 25 times 15 is 365. I'm going to check that on my calculator really quickly. 25, it's 375, I think. 25 times 15 equals, yeah, that's 375. Math is about making mistakes, checking your work, and learning from your mistakes. Again, let's raise that 9 to the power of 2, because there's nothing to do inside of parentheses. So 1/3 times 81 times 6. 1/3 times 81 is equal to 27, times 6 is equal to 27 times 6 equals 162. Now let's check out what I was talking about a little bit earlier. Let's do 1/3 times 9 squared times 6. Now what happens if I multiply 1/3 times 9? Well, then I get 9 over 3, which is equal to 3. And if I square that, I get 9. And if I multiply that by 6, I get 54. So by changing the order of operations, I change the value at the end by quite a significant amount, by 98. So order of operations is very important. All right, that's that. If you need to pause the video, you should at any time. Take the notes, ask questions. Ask questions of your friends in the class, ask me. On this next page, we are simplifying some radicals, okay? On the left, it says steps. Find all the factors of the radical. What numbers can I multiply by each other to get to 68? Well, 68 is an even number, so I know I can multiply it by 2, right? So we've got an example over here on the left at the bottom of finding all the factors, right? That's that right there. So if I'm finding all the factors, let's see. I'm going to find all the factors. Okay, I know that 68, I don't don't like that color. That doesn't work very well. I'm going to go back to black. 68. I know I can divide that by 2. And if I divide 68 by 2, I'm left with 34. Okay, now 2 is a prime number. I can't divide it by anything else and get a whole number. And 34 is not prime. I can divide that by 2 again. And 2 times 17 is equal to 34, or 34 divided by 2 is 17. And now I have all prime numbers, and that's my goal with this activity. So we started with the square root of 68. So all of these things are actually under a square root symbol. Okay? So I actually have the square root of 2 times the square root of 2 times the square root of 17. The square root of 2 times the square root of 2 is the square root of 4, which is equal to 2. So I pull out that pair of 2's. That pair of 2's is going to turn into a 2. And then that's being multiplied by my other lone prime number, 2 root 17. 2 times the square root of 17. Okay, the other way that we see over on the left there is kind of doing the same thing. Okay, this idea right here. And I can do this a bunch of different ways. I start with the square root of 68. Now, are there any perfect squares that I know that I can take out of here? Well, I know 1 is a perfect square. I know 4 is a perfect square. I can just kind of type those. I can just guess and check. I'm going to do 68 divided by 4. Yep, I find that that's equal to 17. So the square root of 68 is equal to the square root of 4 times the square root of 17, or 4 times 17. And then I can rewrite that, because the square root of 4 times the square root of 17 is equal to what we just wrote above there. And if you don't believe me, check it out. Type it into your calculator. We know the square root of 4 is 2, and 2 times the square root of 17. I've got all prime numbers there. That's as far as I can go with 2 different strategies. 2 different ways of doing that. 2 different ways of viewing that anyway. It's pretty much the same thing though. Alright. These go here, these go here. Okay, on to the next example. The next example says simplify the square root of 92. So again, I can use that guess and check method. 92 divided by 4 equals, hey, that's 23. So I'm going to do the square root of 4 times 23 is equal to the square root of 92, and the square root of 4 times the square root of 23 is equal to the square root of 92. And I know the square root of 4 is 2. So 2 times the square root of 23 is equal to the square root of 92. And those are all prime numbers. This is prime factorization. We're getting out all the prime factors. Okay, and we're going to move on to the next example on the next page. Once again, stop the video whenever you need to. I'm going to keep on rolling. Okay, on this slide, what we're doing is adding and subtracting with radicals. When we add and subtract, we have to look at this value right here. This value right here. Those 3's are the same. So basically all I'm going to do is copy that square root of 3. And then I'm going to take my 2 and my 7, and I'm going to do this. I'm going to add them together. Okay, so 2 plus 7 equals 9. 9 times the square root of 3 is equal to 2 times the square root of 3 plus 7 times the square root of 3. We're just adding, performing this operation right here on the coefficients, on the 2 and the 7. Okay, so in the next example, we've got a radicand of 5 in both of these terms. Okay, so 5 times the square root of 5 plus 1 times the square root of 5. There's 1 square root of 5 right there. Okay, so 5 plus 1 equals 6. And again, I'm just copying that square root of 5 down here. And that's my final answer for that one. When I subtract, it's the same rule. Okay, my radicand has to be the same for me to combine those terms. And then I perform whatever operation it is. I'm just combining these values, basically, a positive and a negative. So 6, oh, what just happened there? Try that again. 6 minus 4 equals 2 times the square root of 2. And if you type 2 root 2 into your calculator, let's see what that gets. 2 second x squared 2, enter. That's 2.828. And then if I type into my calculator 6 times second root 2, close parentheses, minus, open parentheses, 4 second x squared second root 2, close parentheses, enter. And I get 2.828. We got the same value. That's how we check our answer. Type it into your calculator both this way and this way, making sure to put parentheses in the appropriate places. Okay. In our last example over here, we have the square root of, or 2 times the square root of 5 minus 4 times the square root of 3. In this case, my 5 and my 3 do not look alike, so I cannot combine this value and this value. No, this is simplified. I can't take out anything else, right? I've got prime number, prime number, prime number. That is simplified. So I'm going to move on. Pause if you need to. Write what I write. And contact me with questions. We were just adding and subtracting. Now we're multiplying and dividing fractions. The fraction bar tells us to divide. Fraction bar tells us to divide. This little symbol right here is another multiplication symbol. There's so many of them. A little dot, a little asterisk. When you're multiplying, okay, what you're going to do is multiply these values and these values. You're going to multiply the coefficients by each other. You're going to multiply the radicands by each other. So negative 8 times 2 times the square root of 6 times the square root of 3. And what we get is negative 16 times the square root of 18. Now 18 is not a prime number. I can take some values out of there. I know that the square root of 9 times the square root of 2 is going to equal 18. 9 times 2 is 18. This negative 16 is still out here. Now the square root of 9 is 3. So I have 3 root 2 times negative 16. I can multiply my negative 16 and my 3, and that gives me negative 48 times the square root of 2. And you can work back through and type this into your calculator every way that we have written here, and you're going to get the same value at the end every time. when we divide, what we're trying to do is get rid of any radicals in the denominator, okay? And the way we're going to do that is multiply this whole thing by the square root of 3 and the square root of 3. If I multiply the square root of 3 times the square root of 3, what I get is the square root of 9. And if I multiply the square root of 10 times the square root of 3, I get the square root of 30. Okay, now what I wind up with is the square root of 30 divided by 3. Can I take anything else out of the square root of 30? Any perfect squares in there that can be taken out? 1, 4, 9, 16, 25. 30 is not divisible by any of those values. That is simplified as much as possible. That's simplifying radicals. And that is all we're going to do in those class notes today. What you should be doing now is keeping that in front of you, because you're going to use those notes to help you through the classwork and the homework. And I'm going to work out a couple examples of